Let's recap what I just did, but in more generality. So let's say that you have a recurrence of the form an equals c1 times an minus 1 plus c2 times an minus 2. Okay. This corresponds to here's the characteristic. So step 1 is you write down the characteristic polynomial, which for this particular recurrence will be exactly this: r squared minus c1r minus c2 equals 0. Okay, so this is the first thing you write down. So you see this recurrence, you write down this polynomial. Step 2, solve for the two roots of this polynomial. You can either eyeball it or use the quadratic equation or try and factor it. And let's assume that you get, assume you get two real roots, r1 and r2. And this is important, r1 cannot equal r2. So you have to make sure that you get two distinct roots out of this polynomial. If you don't, we'll see what to do in the next little video. But for right now, let's assume that r1 does not equal r2. Step 3, use the initial conditions, typically a0 and a1, to solve for alpha and beta to get a formula of the form alpha times r1 to the n plus beta times r2 to the n, and this will be your final solution for the recurrence. So let's do one more example. Let's assume that our recurrence is an equals an minus 1 plus 2an minus 2, and we have a0 equals 2 and a1 equals 7. What's the characteristic polynomial? Well, it's r squared minus r minus 2 equals 0. And if you use the quadratic formula or you factor this, you'll see that the two roots are r1 equals 2 and r2 equals minus 1. Just to verify that, 2 squared is 4, minus 2 is 0, 1 squared is 1, minus 1 squared is 1, minus 1 is 2, minus 2 equals 0. So these are indeed two roots of this particular polynomial. And so we know that the solution to this recurrence is of the form alpha times 2 to the n plus beta times minus 1 to the n. And we just need to solve for alpha and beta. Okay, so we know a0 equals 2. So we know that 2 equals alpha times 2 to the 0, which is 1, plus beta times minus 1 to the 0, which is 1. And we know that 7 equals 2 alpha plus, let's see, when I put 1 in here, minus 1 times beta. So this means 7 equals 2 alpha minus beta. Okay, so again, we have two equations. Here's equation 1, here's equation 2. And we have two unknowns, alpha and beta, and we need to solve for them. So let's substitute. This implies alpha equals 2 minus beta. So we have 7 equals 2 times 2 minus beta minus beta. So this implies that 7 equals 4 minus 2 beta minus beta. So this implies 7 equals 4 minus 3 beta. And this implies that beta equals this implies that beta equals minus 1. Is that right? 4 minus 3. Yeah, that seems right. So we solve for beta, it equals minus 1. And we also know that 2 equals alpha plus beta, or alpha equals 2 minus beta. So that implies that alpha here, using this fact, that implies that alpha equals 2 minus minus beta, so alpha equals 3, I believe. And so our final solution, substituting in numbers for alpha and beta, is 3 times 2 to the n minus 1, so minus times minus 1 to the n. And this is the closed form solution for that particular recurrent.